can improve social sustainability along with being financially and environmentally sustainable in nature. And a very important aspect, a very important metric that can actually make it happen is knowledge slash information. And thus, it has become extremely important for the organizations to understand the role of knowledge sharing to achieve sustainable growth, especially the aspect of social sustainability. And this current paper that I wrote along with Dr. Shishir Datta, it makes the or points the readers to think about this important aspect, to think about the role of knowledge management, the role of knowledge sharing, the role of absorptive capacity or social capital, how they can actually aid in improving the social sustainability of an organization. To be very more specific, the mining sector in India. So this slide and the following slide basically talks about the various theoretical aspects of social sustainability, including providing a definition, as well as the next slide talks about knowledge sharing. So I really won't dwell much on this, but rather go to the research question, mainly because of the paucity of time. I have 10 minutes to
Sir, can
present.
you please change the slide? It's still on 4.
I don't know what's going on. I am on slide 6 actually. How about now? No?
Okay.
So I
Let's move now. Thank you.
so let me go to the research question. I know I have to go back and then I have to go back to the slideshow mode. I think now you can see a new slide, right, madam?
Yeah, it's visible now. It's on
Can you see
slide 7.
what?
It's on slide 7.
Yeah. It's supposed to be on slide 7. Yeah. Okay. So now, as I said, due to paucity of time, I have skipped the theoretical foundations of the concept or the review of the literature, but rather thought to share the main research question that came to our mind while thinking about this topic. And the research question, as you have said, and I have deliberately put it in italics and red, is what are the critical knowledge sharing attributes that can influence social sustainability in the mining or the energy sector, specifically coal in India? So basically, if you take this research question, it can be dissected into two parts. And the reason why I'm going into this research question is this might interest some of you sitting in this room or someone you know, and this research can definitely be taken forward. And I'll be more than happy to play up a role in it with me, Dr. Datta, and maybe some of you as a collaborative research. So if you break down this research question into two simple parts, the first one will be, does knowledge sharing, the fundamental question, does knowledge sharing play a role at all in achieving social sustainability? One. And the second one is that if knowledge sharing plays a role, or assuming that yes, knowledge sharing is important and it plays a role, what are the critical knowledge sharing attributes that can actually influence, affect, govern social sustainability in the Indian coal mining sector?
Sir, 2 minutes are left. Please try to conclude.
Okay. Yeah. And in order to do that, what we intend to do going forward is one, based on the literature, review of literature on knowledge sharing and social sustainability, we propose the research question, which I discussed over the last minute or two. And we intend to investigate as a part of our future research activities. And if once we identify a set of critical knowledge sharing attributes, we'll try to validate it and assess their relative importance, because as we all know, from a portfolio of important metrics, attributes, characteristics, all of them are never as important as others, as much as we say it in theory. Some are more important than the other, and understanding and knowing which one is more important than the others can form a vital part of future research activities going forward. And the rationale, as I said, behind selecting the mining industry is that its operations are mostly in backward and remote hamlets of hinterland of the country, which lacks basic infrastructure. And there comes the importance of social sustainability. And I'll just take one more minute. Conclusion, I will say that with the energy sector being one of the most important sectors of any economy, whether it be a developing or a developed country, it is expected that they should be more concerned with social sustainability. I am no way undermining any other sector, but energy sector, absolutely yes. And therefore, studying the coal sector in the world's largest democracy, that is India, would serve as a very important starting point for studies and researchers on social sustainability in the mining sector. And once we complete this research going forward, the findings of the current study are expected to aid the policymakers to better understand the role of knowledge sharing in successfully achieving social sustainability and therefore incorporating knowledge sharing attributes to develop and design strategies and policies accordingly. So I will conclude my presentation here and thank you for your time. Thank you for the opportunity. And I also wish to thank everybody, the conference committee, and of course, last but definitely not the least, my co-author, Dr. Shishir Datta from the Western Coalfield, for being of great help and for motivating me to write this research paper. So that's all from my side. Thanks once again. And I think Dr. Datta is here, and since I have to rush to another meeting in about a couple of minutes, would it be okay if you can field the questions, if any, Dr. Datta?
Yeah, if any questions are there,
Please.
we are here to address those questions.
Yeah. So can I stop sharing my screen?
Yeah.
Yes.
Or else we can take it, if there is a shortage of time, we can take it in my mail ID. If you can give us some questions, we can reply on that questions.
Absolutely. Absolutely. And as I said, we'll be more than happy to collaborate going forward for a potential research project, including some research grants, if necessary, if possible, rather. In some way.
Thank you, sir.
Thank
Yeah,
you
thank
so
you
much.
very much. Thank you very much, everyone.
For
you
the
so much,
next
Dr.
presentation, I request Ms. Shefali Mohale, Shri Rahul Kumar and Shri Amrendra Kumar and Dr. P.D. Rathi sir. So please take the seat on the dais.
Now, the next paper, which is presented physically by Mr. Rathi, Converting Waste to Resource, Way to Sustainable Opencast Mining from Sand to Overburden. Please proceed.
Thank you, sir. Vijesh, you will forward the. You will forward. Okay. Thank you. We are speaking on sustainability since last 1.5 days. As far as Opencast Mines goes, overburden is one such problem which needs to be addressed in its totality. You can very well see that 96% of the total coal produced in India is from Opencast mines, and the huge quantity of OB is required to be removed to produce coal from Opencast mines. At present, Coal India is producing about 2.35 billion cubic meter of OB annually, and NCL is contributing about 28% of that. That is 374 million cubic meter, and we have planned to produce remove 478 million cubic of meter of OB in next 2 years. So you can very well see the jump in OB removal, and the stripping ratio is continuously increasing in open cast mines. Next, please. Now let us see the different dimensions of OB removal and how they are affecting and dictating open cast mines in Coal India as well as in NCL. As the stripping ratio increases, the volume of OB tremendously increases. It dictates planning, total planning of the mine. You can very well see this is your Moher Basin, and the whole mines you can see the overburden dumps you can visibly see. The viability is also dictated by the quantum of OB removal in any mine. Also the cost, the space, the maximum space you can see, which we have worked out, is occupied by the overburden dumps. Access to coal, we have to access the coal, and access to coal and layout is also dictated by the volume of OB in mines. And ultimately huge dumps are created. Safety, dust and all related problems after rains, impact of rains, and unpleasant view. These are the issues with the overburden dumps and overburden removal. At present, it is one of the main problems of open cast mines, and it is treated as a waste. And the problem is not small. At present, we have 6 billion cubic meter of overburden in our dumps. So you can very well imagine the magnitude of the problem. Now let us, next please, Vijesh, next please. Let us understand the overburden in open cast mines. What are the possibilities and potential in the OB? Can this problem be converted into an opportunity? What is the composition of OP? Let us try to understand and try to answer these questions. Next please. Exploring the possibilities and potential. At present, I have told you that more than 5 billion cubic meter OB is available there, and in next 23, 22, 25 years, another 11 billion cubic meter will be added. So you can well imagine 16 billion cubic meter of OB will be in our dumps. And if we at all plan, the void left at the life of the mine can be filled up and leveled up with the 6 billion cubic meter of OB. Even after that, about 10 to 11 billion cubic meter of OB is left into dumps. Now what is to be done with this? And there is possibility? Next please. Now let us understand what is the composition of OB. To understand, is it of any use? So what we have tested, we have preliminarily tested the OB and found out that 93 to 95% of OB is sandstone. That is 144 meter out of 154 meter of a typical borehole cross section. So, and then we have tested what is the sand, is there a sand available and what is the quantum of sand. So we found out that 65 to 85% of the OB is sand, and that can be recovered, and it is basically concrete and plaster sand. And then further we found out that 90% silica is present before washing in certain range and 95% after washing. So there is a huge potential of enrichment of the silica content. And we are proposed to have study this year only from IIT, BHU as well as NIRI. Now, suppose what is the possibility of using the silt if we remove the sand from OB? The silt removed can be used for bricks, ceramics, pottery, and you can always utilize the topsoil. Next please. So, what if, can we have another utilization of industrial applications of OB? Yes, and we found out that other than construction, there is a huge market and potential for prefabs, foundry, refractory, glass, GRP pipes, construction chemicals, paints, filtration, solar panels. So huge possibility of creating different verticals from OB. Next please. Now how to segregate this OB from sand? It is a simple process of crushing and washing of the sand. The layout is given here. You can refer it further. Next, please. This is one of the plants we have visited where the OB is converted into sand. Next. Is there a mandate or
Only
a
2
policy?
minutes are left. Please conclude.
Yes, sir. Yes, sir. Is there a mandate? Yes, there is a mandate, national mandate, statutory mandate, as well as company's mission policy mandate. Now, let us see. Next, please. Next, please. Next, please. So, there is a huge market available near Singrauli district. Singrauli district is near the 5 states, boundaries of the 5 states, and there are 58 sand mines, river sand mines in Singrauli district, and about 14 million cubic meter of OB is auctioned for 3 years. So there is a huge potential possibility, and in that line we are in a position to install the first OB2 sand plant in our Amlori mine, and we have a plan to install this sand plant in all our mines. And interestingly, now last but one slide, please. Last but one slide. Yeah. Okay. Will it create job? Yes, it will create huge amount of jobs in plant, transport, construction industries. Will it help in creating wealth? Yes, minimum 3 to 4 lakh crore of rupees is the potential at present value. So you can find out, and what is the timeline it can serve? It can serve for next 100 years. What will be the help in environment? It will help restoring the ecosystem of the rivers surrounding Singrauli district as well as in the country. Will it free land? It has a potential to free land of 17,000 hectares. That is one of the gifts we can give to society around. Will society benefit? The sand will be available at very cheaper rates, jobs will be created, lands can be returned, it will help in the ecosystem. Will it help in reducing import? Yes. If we can enrich the silica and install the solar plant, huge amount of import can be reduced. And even in Tamil Nadu, sand is also imported at this point of time. Will it lead in framing potential policy, national policy? This is very important. At this point of time, when we are mining coal, we are just thinking of coal, not incidentals. To reach up to coal, we have a lot of incidentals, that is overburden and different rocks. So we now are in a position, we need to think while preparing project reports, what is in between up to reaching to the coal, and we need to have integrated policy which will make our coal projects viable. And will it benefit nation? No doubt about it. Now what is the likely, and it is likely to be more profitable than coal. When the coal exhausts, this can continuously be a source of revenue generation for next 100 years. So this is what I wanted to say about the sustainability. This converting OB can be the biggest sustainable step a coal mining company can take. Thank you, sir.
Thank you. This paper is very much important for sustainability and presented very well. Thank you. Now, next paper, an examination of human resource practices in Indian coal industries, a qualitative approach.
Good afternoon to all the dignitaries on the dais and all the delegates present here. The paper basically it examines the human resource practices in Indian coal industries. It is a qualitative study, it is a qualitative approach. So, okay, yeah. Mining is considered to be the second basic primary sector. At present, mining sector in India is facing several challenges. Seismic shifts in technology, increasing urbanization, and environmental concerns are placing enormous pressure on the economy in several significant ways. Coal miners are subject to cumulative effects of arduous work, heavy pace, and environmental pressures from organizations. The demand for coal is continuously on rise due to its ever-increasing need from the growing power sector and steel industries. In this regard, the attributes of human resource in achieving this objective have become very crucial. In any organization, the role of HR practices plays a key role, as the processes driven by the people are the major success factors for any organization. The coal industry is an industry of high economic importance, as it not only contributes directly, but also indirectly through the development of other industries like steel and power industries. Human resources are the most important asset. And the growth of mining industry, more than any other manufacturing sector, largely depends on the quality of human resources employed and the effectiveness of HR strategies to manage these human resources. So with this background, the major objective of the study is to examine the human resource practices in Indian coal industries using a qualitative approach. The study was conducted in 2 stages. In the stage 1, the researchers have reviewed studies from the past 2 decades related to the adoption of human resource practices which is implemented in various coal mine industries in India and across the globe. Researchers have emphasized that the aspects related to redefining the HR issues which are considered vital should be thoroughly examined in the context of coal mining industry. Because throughout the world, mining industries are fighting a range of social, technical, environmental forces that are reshaping the sector, and they require a new approach to management. In the second stage of the study, an open-ended interview was conducted online from 5 HR executives of Central Coalfields Limited, which is a subsidiary of Coal India Limited, an undertaking of Government of India. The stage 1 review of literature. Employees are the cornerstone of any organization, and the role of good HR practices is to maximize their contribution in order to achieve corporate goals. Thus, it is very important to implement HR practices in a view that will help employees to work with full commitment in the organization and simultaneously helping organizations to succeed. Now, Table 1 presents the summary of the relevant studies. The first study, basically, the Fee and his colleagues illustrated how sustainable development can be applied in the corporate mining context. And there were 6 recommendations which were provided by them, like improved planning, improved environmental management, cleaner technology implementation, increased stakeholder involvement, formation of partnerships, and improved training. The second study discussed the psychological and physical issues of the aging workforce, which was based on a recent literature. And the findings revealed that the mining industry needs to accommodate and utilize the older worker as an important resource, and also try to determine the job skill and task requirements of their age, so that they might determine that how the age-related effects can be minimized. The next study explored the link between strategic human resource management and firm performance of the coal mining company in Australia. And the impact of SHRM, they were of the view that the impact of SHRM on the coal industry will result in identifying some best practices, and that will help them to expand the business in a wider world. So the next study by Akagoka and his colleagues in 2008 tried to investigate the economic productivity for coal production. And the findings revealed that the major reasons for the lower productivity was the low technology, inadequate training, there were excessive rate of employment that were responsible for these low labor productivity. The second, next study talked about the HR practices of the mining industry in Zimbabwe's Midland province. And the findings revealed that the employees were treated as valuable, rare and immutable resource. And they employ them in ways so that they can achieve organizational objectives. Then the next study examined the relationship between musculoskeletal pain and distress in the Australian population of the mining industry. And they found that widespread musculoskeletal pain among the workers, they impacted their progress in the industry, and also there was an increased psychological distress among them. So the findings highlight the importance of supporting the mining workforce for sustained productivity.
Please conclude.
Yeah. Then in the next part, in which the questions were reviewed, there were the following questions were asked, like what are the challenges in managing HR in the coal mine workers? And these were the major themes that emerged, like absenteeism, lack of devotion, alcoholism on the workplace, workforce planning management. Then there were questions related to existing high performance practices, and the responses were the incentives, the bonuses, medical benefits, knowledge awareness and enhancement program. The next question basically dealt with what are the key HR issues in their industry. And there were the lack of skilled labor, increasing manpower, increasing salary packages, other incentives, better safety features, education, health. And the last was the major obstacles. What are the major obstacles in coal mining industries in recent times? And it was basically the major obstacles that were found were the environmental problems, emphasis on renewable energy resources, getting environment clearer from the government to keep the business going. So after integrating the findings of the studies that were reviewed and the interview, the following the conclusion were made that the major challenges were workforce planning and management, lack of skilled talent working in the industry, labor turnover and absenteeism. Major obstacles were the environmental problems, resource scarcity, quality, unhealthy and risk-prone working conditions. They basically focused, the HR practices basically focused on the reward and incentives to motivate employees, healthier and safer work environment, job skills, job security. And lastly, the issues which are to be addressed in the future is the lack of skilled labor and increasing manpower, organizational effectiveness in terms of quality and quantity of production, education, health facilities for the coal mine workers. So basically, the agenda for the future is that the HR managers should be equipped with the people, processes, and technologies that can transform the industry. So first we need to change our thinking. We need to be collaborative and people-focused. Productivity and quality awareness should be improved among the employees. Thank you.
Thank you. Very good paper, presented very well. Now, next paper is a technical roadmap to net zero mining by Sasan Coal Mine.
Very good afternoon to all. The topic is Sasan Coal Mines, a technical roadmap to net zero. So basically we have, the content is introduction, a comparative study for carbon emission for equipments, best practices to reduce the fuel consumptions, and future plan and technologies. Global warming is not a new topic, it's a burning issue right now, and greenhouse gas emissions has increased manifold in the recent time. And net zero emission is inevitable goal for each and every nation. And recently concluded Conference of Party 26 Glasgow Summit, nations have committed to restrict the rise of temperature to 1.5 degrees Celsius. India is also committed for net zero emission by 2017. This chart shows in the last decade from 2006 to 2022, we have increased from 380 ppm to 417 ppm. So how mining is related to global warming? Mining industry is heavily dependent on fossil fuels. Mining is, according to reports from McKinsey and the consulting groups, mining is responsible for producing around 7% of global greenhouse gas emissions. In typical mines, around 70 to 80% of diesel is consumed in hauling and loading operations. And in our scenario, in India, most of the hauling and loading operations are diesel operated. This is basically a global giants have committed for their reduction goal and net zero timeline. Basically, we can see that BHP, you have a timeline for net zero from 2050. Most of the companies are committed for 2050. And in Indian context, only Vedanta has committed for 2050 timeline. This is a comparative study for how, why we have choose 240-ton electric drive dump trucks, not the 100-ton mechanical drive dump trucks. basically the carbon emission ton per hour is depends on the fuel consumption and conversion factor that is derived from the study of mining environment management, a paper that is I think on the internet and it's well renowned. So conversion factor for the dump trucks, for mechanical dump trucks and electrical dump trucks will come in the next slide. Basically, this is the emission data for both the machines, for the engines, what we are using and what the 100-ton dumper is using. There is a vast difference we can see from this. Basically, I will not go in detail. This is these are the benchmarking basically done from the performance data of my mines and the 100-ton dumper with PC2000 excavators. So we will come to the next slide. This is a conclusion of the both the slides. Total carbon emission for coal operation for 240-ton 4400 AC dump trucks and the electric rope shovel is 14 metric ton, and for 100-ton the mechanical drive is 15 metric ton, and for OB it is around 69, and for same 100-ton is 85. So total comes around 83 and 100. So there is a reduction of, there is a carbon reduction of around 17 metric ton. That is in percentage it is 21%. That is means not a minor change. So we will come on the next part, the best practices at Sasan coal mines. We have a mine management system that monitors every component of shovel, dumper, cycle time analysis, payload monitoring, haul load, heat mapping, dumper, RPM trend, fixed line water sprinkler, use of fuel injectors and G saver cards in dumper, use of waste oil in ANFO. So basically this is the shovel cycle time and the dumper queue time. We can see the two component data that are not productive is spot and queue. As a mining engineer, we all know that we want to reduce this. With the help of fleet mine management system, we analyze all those data. I will focus mainly on the queue time. In present year, we are on around 0.82 minute per trip, and in 1920 we were around 1.12 minute per trip. So for whole OB removal target, we would have been a time of around 9520 hours for all the dumpers in 1920 in queue, and in 21-22 we have reduced it to 6,970. And we convert it in terms of carbon emission, it has come down from 6.43 to 4.70. It is around 26% reduction. This is dump truck payload monitoring. We monitor the payload of every dump trucks with the help of fleet management system. We have a payload monitoring system installed in every dump trucks. So we have a data for starting from we can see 16-17, and we are 21-22. From last 3 years, we have achieved our target around 217 ton, and we are consistent. So if we have around 207 ton at that year, we would be requiring 517, basically 5,17,391 trips, which has been reduced to 4,94,365 trips. There is a saving if we take 16-17 as a base year. There is a saving of around 23,000 trips, and our average productivity for every dump trucks is around 2.5 trips per hour. So it comes around saving of 9,000 hours of dumper and 3,040 ton of CO2 emission reduction. We all know that haul load is a very important component for fuel consumption, productivity, as well as safety. But how we do it? What is the means to do it? Haul load heat mapping is the means for us. Basically, we are using
2 minutes are left.
Haul load heat mapping. We are doing it to reduce and to implement all the things that there is a lacuna in any part of the haul load. This is dumper RPM trend at dumping. Basically, operators have a behavior to run dumper at higher RPM in dumping. That is not correct, because it doesn't reduce the dumping time. It has been basically, there's a lots of a study on this topic. We have done it, and there is around 76. By doing this, we can reduce saving of diesel can be around 23,500 liter, and carbon emission can be reduced to 76.5 ton. And these are ANFO explosive. Basically, we use lubricant oil in place of diesel for 50%. That can save up to 2 metric ton of CO2 equivalent per year. And this is GE Fuel Saver Card and Renter system that optimizes the fuel supply to engine. So what is next? What is future? So the future is dual fuel ignition system, LNG system. As we all know that LNG is cleaner fuel than diesel, it will reduce the CO2 emission also on the costing part. So we have implemented it for 8 dump trucks. But right now there's lots of fluctuation in global prices. So we are in a study mode. The second is trolley assist dump trucks. It is globally accepted for electrical drive dump trucks, which can reduce your fuel consumption by 60 to 70%, and same is for CO2 emissions. Next one is hybrid dump trucks. Every electric dump trucks runs with a wheel motor, with electrical wheel motor, and these dump trucks become, when go on down gradient, the wheel motor becomes generator, and that energy is being dissipated as heat in the retarder grid. Basically what the concept is, the waste heat will use to charge the battery system that will provide power when it is running in the normal condition. We can basically reduce the fuel consumption by 25% and carbon emission reduction by 23%. And hydrogen as a fuel, we all know that the next big thing is hydrogen, because it's a zero carbon neutral fuel and it has more energy per unit weight. But research is also on the way for hydrogen generation as storage and transportation. Another is solar power generation at saturated dumps. One of the company in Europe is doing it. They will be doing it from 2023 onwards. It will help us to achieve the target of carbon neutral world, and also it will help in mine reclamation that has an aim for sustainability of the area. So we come to the conclusion. What is conclusion? In today's world, every emission counts. First, the beauty of mining industry is that the carbon reduction is directly related to OPEX cost reduction. And we are very far, we are laggard in this situation that we have no emission index for mine site. So first we should measure, we should develop a carbon emission index, we should measure, analyze, and then reduce it. Carbon capture and sequestration systems will be developed at every mine site, and the implementation of modern and frugal technology shall be expedited in mining industry. With this, I have come to the conclusion. There is a question, how we will achieve our net zero and when? This is a big one and we have to do it. Thank you.
Thank you. Now, next paper is on unemployment in Singrauli youth and empirical experience, presented by Mr. Amrendra Kumar.
Good afternoon, everyone. So this is a post-lunch session, and we all might be having a kind of laziness here. So I'll be very quick, and I'll try to make it a bit interactive. Sir, thanks to Chairman Sir, Co-Chairman Sir, and Rapporteur Sir, and my CODAS partners here and dignitaries here. And taking to my presentation, I am going to talk a bit about the Sustainable Development Goals that has been designed by UN agency in 2015. And measure stress, if you see on point number 8, 9, and 10, it's about decent work, and then industry and innovation. And then at 10 number, we can see reduced inequality. My entire paper is on these 3 things only. And my flow of presentation is, I'll be talking about some practical global examples, then unemployment discussion with respect to local area that you all might have experienced too. And then my sample details, social issues and social construction with respect to unemployment and gender, and way forward to the solutions. For last 2 days, we are listening a lot about technological upgradation and automation and so many so many things about machine. My last to last speaker talked a bit about HR, and then soon delegate from author from Sashan talked about machine. So between machine and man, there is one thing that is either employment or unemployment, and that is what my paper is all about. And my debate is that one of the biggest apocalyptic crises in the global economy today is the loss or obsolescence of existing jobs due to automation and rapid change in technology. So myself being a social science graduate, I'm a bit opponent to all this automation and technology induction in the industries. Why? This picture you all might have gone through. In 2009, there was a helicopter service provider, there was a pilot, and then there was a cameraman, and they all used to earn well. Only in 10 years, all lost job except for one who is a drone operator with a camera. So you can see a drastic 60% reduction in the job altogether. And this is what is happening all across. Some more examples that I say which could not keep themselves abreast with the latest technologies or could not understand the market dynamics and now they are nowhere, like Kodak, Ambassador car, AMW trucks, Dalda, which was once synonym of hydrogenated vegetable oil in India, and then Nokia. I think none of us might be having a Nokia phone here, which once everyone started with. Anyone has that? Nokia phone? So these are some of the global examples where we can say and understand that if you don't keep yourself abreast with the latest technology or understand the market dynamics, you won't be able to keep yourself engaged in the market or earn. Now coming back to my paper, that is unemployment rate, 7.4%, it's all across India, and in Singrauli, it's something about 8%, urban, rural. Now, as I had been working as a CSR officer, as an R&R officer, these are the set of theories that I have read about unemployment, voluntary, open, disguised, seasonal. We have written papers about all this. But when you go in the field, the real unemployment, when you try to study, it's very different. The problem that with the local youth is that now we are turning from labor intensive to capital intensive industry. So we are introducing lots many technical gadgets. We need people who can engage with they should be technically well advanced. That like HMV vehicle, like tractor operators, they cannot run our Volvos. And every now and then we keep getting call from local administration, local MLAs and all that please engage some people. But we have our own limitations in the same. Then there is one word, no proper input management system. Since in Singrauli, if you are reading newspaper and if you are saying there is, every now and then there is a protest in any of the mine. You might have seen that. So why is that? Because certain number of youth who are not engaged anywhere, they come and try to protest for our blasting or mine expansion. And this is, if had the case been that these people are engaged somewhere in the agrarian economics, which is not a case in Singrauli, because here we have very limited scope in agriculture. Even the flowers that we are seeing here, they have been imported, taken from Calcutta or some other district. So the crop growing pattern that we call input management system is totally dependent on rain-fed agriculture, rain-fed. So they cannot take much crop, no cash crop, and floriculture and all, they have a very high limitation in the same, and so they are not engaged anywhere. Then lack of clarity and skill sets. When I was interacting with, conducting this FGD about my paper, I interacted with 64 local youth. And when I was interacting, if they can migrate somewhere, if they want to go for SIS security or for CPET and all through our CSR initiatives, they just refuse. They don't want to go outside because they find it very convenient
Amrit,
and...
please try to conclude.
Sir. Sir, this is my sample. Societal social construction I wanted to talk about, sir, but as the time constraints. Enterprising skills, as I said, if you all might have moved to the local villages and all, you must have seen that there are certain women walking, or people are not only tripling, there are 4 to 5 person on a single bike. So I always try to understand why don't they come up with some public transport system on private basis. So people are not taking any, taking any enterprising skill to develop any kind of transportation of their own and make earnings. Like one more example I want to quote here, that when we all wanted to go for an IIT or NIT, the primary target was to get placed. And we used to study the placement data. But when we talk about doctors, we don't see that आप एम्स में जाने पे या PMCH में जाने पे या BHU मेडिकल में जाने पे आपका क्या placement होगा. So there is a tacit understanding that doctors can create job of their own and they can create job for others as well. So that is an enterprising skill that is required for other courses as well, sir. Then micro enterprise counseling is again very important thing, that I've seen people are starting up with certain enterprise, they fail and then they don't take up job. Then since we have taken their land and one person is getting job on basis of 2 acres of land, what they do that the rest of the family come and protest for balance family members' job, and this is creating a problem for us. These are what are the things that limited early education, economic class, underemployment, these are the things that are making them more vulnerable. And sir, if I get 2 minutes, I want to discuss about the social class and all.
Just to complete in 1.5 minutes.
Sir,
try to conclude immediately.
When, sir, we see that there are certain sector of people who want to take up a certain level kind of job, but they are not allowed to. Like either they are not well built. One thing that what I have seen in the Singrauli district, that the caste dynamics also limit someone to take up a particular kind of job, because we have transportation supervisor and all in the private industries, but a certain that is dominated by a certain social segment only, and others are kept aloof because they don't have proper social contacts and they want where they can earn. Limited communication skill, limited enterprising skills and all, and women participation again is very limited. And again, sir, as discussed in my third slide, educated unemployment are also there. Just because they have gained a good education, they think that that will be downgrading if they get engaged somewhere else. So they also quit the job and they are unemployed. Human capital formation, like this is just like adding skills to the people and then engaging them. Then concept of common resource pool should be deliberated by the land and revenue department of the state, because you see we want to take up certain fisheries and all, so there is very limited land that is government land, and if government allows then through our CSR we can take up fisheries and goatry, etc. And research and development and design thinking is very important for rural youth so that they can get engaged in some earnings. Entrepreneurship council through corporate innovative cell. As I said, sir, they start something, but they are not able to continue long, and then they are again unemployed. And financial training for a sustainable R&R. So this is one thing that you all have headed as a area general manager sometime in MP, and you have seen that we offer a compensation package to a tune of 1 to 1.5 crores also. Still, after 5 years, you can see that these people are back to unemployment. Why? Because they have not assiduously used the R&R package that was provided to them. So, and they either buy vehicles or spend on luxury, and then again they are unemployed. So this is one thing that we should start with, financial training on sustainable R&R. And these are some of the pictures that we have engaged ourselves in mobilizing people for a skill development and training through Gram Sabhas and all. Local Tahsildars, SHO and police etc. goes with us so that we can interact and mobilize for some placement linked services. Thank you.
Thank you. This paper was very much related with the burning problems of this country and the world. Thank you.
Thank you. I request Chair, Co-Chair and Rapporteur Sir to please kindly present our authors and speakers with certificate and memento. Ms. Shefali Mohale.
Can we have a big round of applause? I request Chairman Sir, Co-Chairman Sir and Rapporteur Sir to present Certificate of Appreciation and memento to Shri Rahul Kumar from Sasan Power Limited. We had with us Shri Amrendra Kumar, Deputy Manager CD from NCL Amlori. I request Chairman Sir to please felicitate Shri Amrendra Kumar Sir. I want all of you to please put your hands together for all the speakers. Now I invite Shri Pankaj Goyal, Shri KP Khaitan and Shri Praveen Kumar from Khadia project to please take their seat on the dais so that we can start with the last three presentations of this session. I again request Shri Pankaj Goyal, Shri KP Khaitan and Shri Praveen Kumar from NCL Khadia to please take the seat on the dais. Shri KP Khaitan sir is here. Now I hand over the session to Chairman sir for further proceedings.
Now, this next paper which will be presented by Mr. KP Khaitan. This is importance of integrated real-time OTR tire pressure and temperature monitoring system.
I'm starting the paper. Nobody else has come. A very good afternoon, and thank you for giving me an opportunity to talk about a subject which I'm passionate about. It's digitization in the mining industry. I've been involved in this since 1993. Today I'm talking about a very specific technology which is already being used and already integrated at several operations, and we want to focus on this for Coal India opportunities, because Coal India is embarking on digitization as a major productivity and production increase opportunity. So specifically I'm talking about particular sensors which will enable you to improve your equipment reliability. And it's a known fact that if your reliability increases even by say 4%, the productivity increase opportunities in a factor of 2 to 3 times more. So we are talking about specifically tire management system. So, and as you know, tires are used for our dumpers, loaders, water sprinklers, graders, etc. And so the basic thing is that the shape of the tire requires to be optimal to carry the load of the material or ore, overburden, coal loaded on the dump truck. If you have less pressure, you will be under-inflated, and if you have more pressure, you will be over-pressurized. Both these overpressure and under-inflation are deadly for the tire. You need to have optimal, because the actual load of the equipment and the material is carried by the air inside the tire. Okay. If you, this is a failure analysis of tires, and the number one reason for failure is tire pressure issue. There are other issues as well, but 25 to 30% of the problem arises with underinflation and overinflation. So what does, why do you need to manage this? You need to manage this in order to get the best possible life of your tires, which are expensive. And if your tires are not performing properly, or they have, cuts, and your equipment is going to be idle due to breakdowns, so your productivity will go down. If you're underinflated, your fuel consumption will grow up, and various other things. So the technology is very simple. You have sensors on the tires, and you have a monitor inside the driver's cabin, which is getting RF signal from the sensors, which are checking the pressure and temperature every 7 seconds, 24/7. And they are reporting the current pressure and temperature of the tires. And this is what a sensor fitment looks like. It's quite done properly, professionally, with chain tethering for tenable installation. And we use T connectors so that we don't need to remove the sensor to inflate the tires. Sensors can work in very dirty and arduous conditions, and it's proven that it will not get affected due to mud and various other factors. And the monitor inside the cabin accesses the data and automatically generates alerts if there is any condition such as low pressure, high temperature, high pressure mismatch, etc., etc. Now the game changer is that you can access the data remotely or at your control room by interfacing with serial connectivity available through RS-232 port. This is a picture of a private sector mine in India who have integrated with the TPMS monitor, and they are accessing in their fleet management control room. We call it OITDS in Coal India. And they are accessing that information in the control room to see what is happening, what is the current pressure. If there is an alert condition, they get automatic alerts. in case you don't have OITDS, you can still access the data remotely using a specialized device which will put the data into the cloud, and one can log in to see what is happening with the vehicle. This is already working at Gevra project, and I've got a picture. This is a Caterpillar 793D 240-ton capacity dump truck, and we can see live what is happening, and if there is an alert condition, you get email directly on all the maintenance people who are required to get the alerts. So the importance of the technology in terms of sustainability is very important, that if you have properly inflated tire, you will use less tires, burn less fuel, fill less landfills, and various things. So there is a win-win thing in terms of environmental issues using this technology. So in the end of the day, what we need to see is well-used OTR tires, where you have used the entire tread, and the tires have been used up to 85% of their tread depth, and we have optimized the performance. So I'll end my small talk now, and thank you very much for your time.
Thank you. Now, this next paper is a plan for demineralization of coal to reduce ash content using magnet fields. This shall be presented by Mr. Praveen Kumar, NCL Khadia.
Thank you, Chairman, sir. Respected Chairman, sir, Co-Chairman, sir, members of panel, management team ICOMS 2021, and each and every person present over here. Today, through a plant of demineralization of coal to reduce ash content using magnetic fields, I want to show a better future. Considering ash analysis of coal dispatched by different projects of Northern Coalfields Limited, according to quality control departments, there is about 25 to 45% of ash causing mineral content in coal. Presence of these minerals are not homogeneous, but there are variations in proportions of minerals. But types of minerals found is same. This pie chart is of the ash causing mineral content of seam of Khadia block of NCL from borehole CMSK 31, showing proportions of major minerals found in coal. This table contains 16 complex minerals found in coal seam of lignite coal, ordered according to the percentage occurrence. First column is of names of minerals, second is of chemical formula, third is of the magnetic field strength required to magnetize such minerals, and fourth is the magnetic susceptibility. The higher the susceptibility, the more amount of magnetic force will be generated on them. Fifth is the magnetic behavior. These minerals, along with coal, goes directly to the furnaces and then burn down to ashes and serves no purpose. Burning coal at power production facilities produces a solid waste called fly ash and numerous other pollution-causing gases like carbon, oxides of sulfur, nitrogen and carbon, and methane, and PM2.5 and PM10. Trend of pollution-causing gases from 2003 to 2019 from satellite data has been shown, and in which the straight lines marks the installation of a new power plant. After 2012, carbon dioxide has an increased rate, and similarly methane and oxides of carbon, sulfur and nitrogen Each pollutant may originate from different sources, however, they are interlinked with fuel combustion and or industrial activities. In addition to the crippling effect on the environment, pollutants have an adverse effect on human health and crops and ecosystem. Although government has taken several steps to minimize these emissions, still Singrauli has been declared as critically polluted by Central Pollution Control Board. Considering the national AQI data of Central Pollution Control Board, Ministry of Environment, Forest and Climate Change, and the efforts of different individuals as well as organizations across the Singrauli and Sonbhadra area, it seems necessary to reduce the pollution. When minerals causing pollution will be filtered before coal is burned, slowly quality of air will increase and eventually air will be more breathable and pollution free. Using magnetic behavior of minerals present in coal seam, filtration of coal is possible. Each and every mineral found in coal seam is susceptible to get magnetized under the influence of magnetic fields, or just it depends upon the magnetic field strength to attract or repel. Thus a precise and intense magnetic field regions is all we need to filter minerals from coal. Minerals found in coal seams is classified broadly into three magnetic behaviors, that is ferromagnetic, paramagnetic and diamagnetic. Ferromagnetic and paramagnetic minerals are attracted towards magnet, while diamagnetic minerals are repelled from magnets. Carbon present in coal is diamagnetic with the least diamagnetic constant of all other minerals found in coal. That means it is least affected mineral as compared to all other minerals found in coal seams. Thus, we can easily filter minerals away from coal. This is the basic idea behind this filtration technique. Details of magnetic field arrangements and filtration process. Arrangement: 2 inlet tubes fed by a pulverizer, 4 conveyor belts, 2 vertical and 2 inclined, 2 electromagnets providing intense magnetic field region near the sides of chamber, 4 outlet tubes, 2 for pure coal particles and 2 for diamagnetic particles. Filtration process. Pulverized coal particles will be dropped from inlet tubes. Paramagnetic and paramagnetic minerals will be taken away using conveyor belts. As the paramagnetic and ferromagnetic particles are attracted towards intense magnetic field regions, they will tend to go towards magnet and stick to the vertical conveyor belts and will be taken upward using the teeth of vertical conveyor belts, and will drop to inclined conveyor belts I1 and I2. Diamagnetic minerals will feel a force of repulsion from both magnets and will drop near the D1 and D2 regions and will drop in D1 and D2 outlets. It's analogous to the haystack removal from rice that we see in villages. Pure coal or mineralless coal will drop in C1 and C2 outlets. Economical analysis. Because the mineral content in our coal that we dispatch, the average value is of grade of 8, 9, 10 or 11. After filtration, it will be at least grade 3 or better than 3. For example, 1 ton of coal is valued 3,000 rupees. Now after filtration, 600 kilograms of filtered coal only will be valued 3,600 rupees at least. We do face huge economical losses due to mineral content of coal. And there is a good amount of iron and aluminum in coal seams as well. These minerals can be sold separately and will add more economical benefits to the company. Environmental benefits. When minerals which are causing fly ash and invisible particulate matters will be filtered out before burning, the air will be more breathable for each and every organic elements of ecosystem of Sonbhadra and Singrauli area. This will increase average life expectancy of residents of Singrauli and Sonbhadra area. Will decrease chances of severe frequencies of climatic conditions changes. This will certainly decrease chances of lungs disease caused by air pollutants. At last, I would like to say Through this process of filtration, every cubic meter of earth that we unearth will be valuable. Thank you.
Thank you, Mr. Praveen. Now, next paper which shall be presented, that is Fleet Management System, a flexible data-driven approach by Mr. Pankaj Goyal. Please.
Thank you. I believe I'll be presenting on behalf of Pankaj. My name is Jason van der Vat, and I will share our presentation with you now. Thank you very much. So our topic is a fleet management system, a flexible and data-driven approach. My name is Jason van der Vat. I am the founder and CEO of AVA, and I'd like you to explore with you today the use of exhaustive time models to optimize fleet. So thank you for having me, and I appreciate the opportunity to present to everyone. I'd like to start with a small experiment. Just if you could consider a dice in your mind, when you throw a dice, it has a chance to either be a 1, a 2, a 3, a 4, a 5, or a 6. At no point can it be two of those numbers at the same time, and at no point can it be 0 or null. So dice is both mutually exclusive and collectively exhaustive. It must give you an answer, but it can only give you one answer at one point in time. And if we think about haul trucks in the same way, every time a haul truck moves, it has both distance and time. This is a small snapshot on the right, happens to be from our software platform, but we've got 2 GPS coordinates. And that distance or time can be classified as an activity. What this means is doing it automatically using GPS data. We're not in a position where we are reliant on manual inputs to create these exhaustive time models. And every single segment of time can be defined as one of the categories in our time model. This is our time model where we go from calendar hours all the way down to the overall equipment effectiveness, and every single movement of that truck gets logged into that time model, and all the stationary events get logged in that time model as either a form of operational delay or cycle delay. The real interesting part, I think, about this is when we consider we only have 24 hours in a day, how do we use that time to maximize the throughput of our fleet? So one of the ways we visualize at AVA the fleet management system and that time model is we put it into a value driver tree that allows us to maximize our tons per truck. Maximizing that is really how we get the most value in the optimal haul routes for our truck to loader allocation. So this section that I've pulled out is just for the average cycle time. It's something I think we're all very familiar with in Opencast mining. We've got a certain amount of time to load with. We travel full, we dump it on the dump, travel empty back to the loader. And at any point during that cycle, if the truck stops, we consider it cycle delay time. And that cycle delay time is really the target for stationary time on the journey. It's the impact of all the stop streets, the 90-degree bends, ancillary equipment getting in the way of our haul trucks. And those added together gives our average cycle time. This comes from a medium-sized gold mine. It's the case study presented in our paper. And from that, we can very clearly see, I've removed the targets to keep the mine site confidential. But from the makeup of these elements, you can see that the loading time is extraordinarily high. It's higher than both the travel time full and the travel time empty as a component of the average cycle time. So the time model picks this up as a constraint very, very quickly. And what we did then was took all the loading, the filling and the queuing time, and we put it on a box plot per shovel. So when we lay the data out like this, it becomes very evident that there's excessive amounts of queuing. We can see there that the average is 7 minutes and 6 seconds on the queuing time, but the filling time average is only 4 minutes and 43 seconds. And the reason that this has happened is if you look at the median, or the most repeated value in the set, it does actually pair up with the loading time. So when a supervisor would be down in the pit with a truck, he would actually see that the shovel has a truck and maybe one in the queue. But this amount of variation means that when he's not there, it can often be that the shovel's left hanging, or that there is 3 to 4 trucks in the queue at any point in time. And it's the management of that variation that wasn't visible at this particular gold mine. You can see in certain shovels it's even worse than in others. So our goal is, how do we create a platform to manage, to actually control the variation while we reduce the number of trucks at this particular gold site? So we followed a very simple approach, very similar to the Plan, Do, Check, Act cycle, the PDCA cycle. It's define, measure, analyze, improve, and control. And what we did was created an alert. And this alert would trigger every time that the queuing time exceeded the filling time. So it was still rather conservative, because we understand that there is variability in any process. So if you had it set to only half of the filling time, you might end up in a point where you increase your hang time on the shovel without necessarily optimizing your throughput. So we kept the alert to say when the queue time exceeds the filling time, it will alert in their control room. This is a snapshot inside the control room, and then we put that within a control limits feedback loop. So they could now slowly remove trucks from the fleet across the 4 shovels and actually observe the number of alerts come down, and at the same time measure their filling and their queuing time in real time per shift. So to create the control mechanism allows that very precise removal and reduction in truck fleet. In conclusion, we estimated that they could remove a full 3 cat trip 7s from the fleet. At the time of this presentation, we've currently got down to removing 2 of those cat 777s with no impact on production to date. And GPS exhaustive analysis is cost effective. It uses very simple GPS tracking units, and our business model is designed to leverage that. And it can make a really large impact in terms of cost of delivery of the same number of tons on a daily basis. That's all I've got. If there's any questions, I'd love to take them. Thank you very much. I appreciate your time.
Thank you. This is time for question and answer. The participants who are interested to ask any question may ask from the presenters. No question? Now I request Mr. Now the one paper which shall be presented, that is application of directed energy deposition based additive manufacturing in repairing, remanufacturing of HMMs. Now please start.
Good afternoon, sir. Good afternoon to everyone. So my paper is basically on applications of direct energy deposition based additive manufacturing in applications for repairing of HEMM spares. So basically the idea for this came when we have NCL has a pilot project on 3D printing. So I was like very curious to know whether what application can be, it can have in repairing of HEMM spares. So this is the DED method. I won't be going into so many details because of shortage of time. So skip the video, okay. Okay, now, so I have a few, I went through a lot of published works, okay, which detail about like all those repairs which have been done successfully. And so first case was repair of dies and molds. So these are the three, Grum et al. And Borrego et al. They have repaired dies and molds using this DED method. And they have found that this method is very successful in repairing of these spares, the dies. Sir, it was a demonstrational video. It shows. Vijish, can you please help me? Volume, please. So this is the tip of that laser. From both sides, you would see powder coming, and then there will be a laser shot, and it's a not running properly. Close that. Close. So I'll show the video to sometimes because it was probably not working properly. This is a very important one. Kohler et al. They have attempted to repair a marine engine crankshaft using direct energy deposition method. The third case is Wilson. Wilson et al. They repaired an entire aerofoil using DED method. These are aircraft parts which have been repaired using DED methods. So drawing parallels from that, I can these are the prospective applications which we can have for remanufacturing of HEMM spares. There are engine spares like crankshaft pistons, gear applications, engine turbochargers, propeller shafts, hydraulic distribution valves, and many more. So this is the target which this has been repaired, and this has been repaired, and that is the final product. Okay. So the way ahead is that we have to first of all do a lot of study on our base material metallurgy. We have to take the economics of repair into account because this DED method is an extremely expensive process. And last of all, we need algorithms, AI-based algorithms for this purpose. And the last one is that post-DED heat treatment, that is an entire area which is completely unexplored till date. So we need to do a lot of work in these all fields. And with this, I thank you all, guys.
Thank you.
So, वो वीडियो फाइल एक दिए थे ना साथ में, इसको वीडियो फाइल this is the powder coming. This is the laser beam flash, and the deposition happens.
Thank you. This is very useful
you,
and
sir.
very interesting paper
Thank you, sir.
which was presented. Now in this technical session, Opencast Mining Towards Sustainable Paradigm, total 9 papers were presented, 2 by virtual mode and 7 by physical mode. All the papers which were presented, they were very much relevant with this mining industry. The first paper which was presented, that was role of knowledge sharing in achieving social sustainability. Definitely sustainability is very important for any business. It was presented by Dr. Anirban Ganguly, and it was presented very well, and we gathered more insight in this regard. Now, second paper was converting waste to resources, was presented by Mr. P.D. Rathi. This was extracting sand from overburden and silica for usable resources. Third paper which was presented, that was an examination of human resources practices in Indian coal industries. Definitely, if human resources are not properly utilized and developed, no business or no industry, nothing, no development is possible. This was presented very well. Fourth paper which was presented, that was technical roadmap to zero mining by Sasan coal mine. This was for just reducing this carbon in our industry, carbon and mining industry. This was achieved by increasing the capacity of the mining equipment, and there was saving in diesel, fuel oil, and it was presented very well. Now, the fifth paper, which was unemployment in Singrauli youth, was presented by Mr. Amrendra Kumar. Now, this is very burning subject and problem everywhere, that employment is now getting reduced. The sixth paper which was presented, that what importance of integrated real-time OTR pressure, temperature, pressure monitoring system, which was presented by Mr. Khaitan. This paper was very much relevant for big open cast mines where we are using this heavy dumpers, tire-mounted equipments. He has given very good insight for improving this productivity and increasing the life of the tires and saving this environment also by reducing the consumption of the fuel. Seventh paper, which was a plant for demineralization of coal reduced ash content using magnetic field. This is very important, by which we can reduce the waste material in the coal, and by which this utilization of coal will be better, and will be environment friendly also. Eighth paper, which was presented by virtual mode, that was fleet management system, a flexible data driven approach. Definitely for bigger open cast mines, this fleet management is very important for improving the production and productivity of the mines, and for safety point of view also. It was presented very well by Johnson, Vander, Watt. This ninth paper which was presented, that was application of direct energy deposition based additive manufacturing, repairing and remanufacturing of HEMM, by Mr. Nitun Kumar. It was very interesting paper, and we have seen in video also that this is very useful for repairing of these costly spares, and by doing so, we are not going to save only money, we are going to save time also. Now, this session was very much useful for our industry, and especially in coal mine also. Now, I thank to all the presenters who has presented all these papers. I thank also these participants who has given their time and listened patiently. Thank you.
Thank you. I request Chair, Co-Chair and Rapporteur Sir to please present our authors, presenters with certificate and memento. Mr. K.P. Khaitan, sir. Great round of applause, please. Mr. Praveen Kumar. Mr. Nitul Kumar. Put your hands together, please. And Mr. Pankaj Goyal on behalf of Jason Wonderwort. Mr. Pankaj Goyal. Thank you, sir. With this, we conclude our last session for ICOMS 2021.
I thank our chairman, sir, Shri J.P. Dwivedi, sir, for chairing the session and deriving out a number of suggestions for ICOMS 2021. I thank Shri L.P. Godse, sir, GM Bina, for co-chairing this session. I also thank Shri Suman Saurabh, sir, GM Production, for being the rapporteur of the session. I thank you all, sir. I request my stage management team to please prepare the dais for valedictory session. We are about to start with the final valedictory session in the next 10 minutes with the arrival of our chief guest.